Welcome back guys. Now let's discuss about the types of lower motor neurons. You already know lower motor neurons arises from where? Lower motor neurons arise from the spinal cord, from the ventral horns of the spinal cord. You know. Now these lower motor neurons are further divided into subtypes. Look at here, lower motor neurons are divided into alpha motor neuron and gamma motor neuron. Now where these lower motor neurons will go? You know, lower motor neurons are going to cause the contraction of the skeletal muscle. So both this alpha motor neuron as well as gamma motor neuron, they are going for the skeletal muscle only. Now look at the skeletal muscle. You have to know some important things. Sir, in the skeletal muscle, imagine this is your biceps. There are these extrafusal fibers present. Okay, these are all extrafusal fibers which are present outside. These are nothing but the myocytes which contain actin and myosin. So extrafusal fibers are nothing but the myocytes which contain actin and myosin, which will help in the muscle contraction. You know. And there is also intrafusal fibers. What are these intrafusal fibers? Where they are present? These intrafusal fibers, they are present in the specialized apparatus. This specialized apparatus, what you are seeing in the center, in every skeletal muscle, this apparatus is present. This blue color apparatus which I am highlighting there. So this is called as a muscle spindle. Okay, intrafusal fibers, they are forming your muscle spindle. Or you can say the muscle spindles are made up of the intrafusal fibers. So now tell me student, the skeletal muscle is made up of how many types of fibers? The skeletal muscle is made up of two types of fibers, extrafusal fibers and intrafusal fibers. Extrafusal fibers are nothing but actin myosin, and in these intrafusal fibers are forming a muscle spindle. Okay. Now my question to you, sir, when a muscle is contracting, see when a muscle is contracting, okay, so the entire, when the muscle contracts, do you think is it the extrafusal fibers which are contracting or intrafusal fibers, or the entire muscle will contract? See, when a muscle is contracting, when the entire muscle is contracting, it's the extrafusal fibers, remember it's the extrafusal fibers will contract, as well as this intrafusal fiber, that is a muscle spindle. Muscle spindle also contracts, both will contract. Okay. So in order to contract this extrafusal fibers, there is a neuron coming like this. See, there is a neuron which is going to cause the contraction of the extrafusal fibers. The name of this neuron is called as the alpha motor neuron. Okay, now you know, sir, alpha motor neuron causes the contraction of extrafusal fibers, and to contract this muscle spindle, there is one more motor neuron coming here, that is the gamma motor neuron. Okay, gamma motor neuron. Gamma motor neuron causes the contraction of the intrafusal fibers. Alpha motor neuron causes the contraction of the extrafusal fibers. Okay, so these are the two types of lower motor neurons. See, the two types of lower motor neurons, they are coming to the skeletal muscle, they are innervating the skeletal muscle, their innervation is little different. Okay, either extrafusal fibers or intrafusal fibers. Now you will be having a doubt, sir, we understand extrafusal fibers, the myocytes, actin, myosin helping in the muscle contraction, that we know already. But what is the function of this muscle spindle? Like, yeah, sir, what exactly this muscle spindle is? Let me tell you. See, these muscle spindles, they are receptors. Okay, they are receptors. So receptor means they should detect something. Are they touch receptors, baroreceptors, chemoreceptors? What do they detect? What they are detecting? They detect muscle length changes. So they are going to detect the muscle length changes, how the muscle length is changing. You may not know it consciously. You may not know it how your muscle length is changing, increasing or decreasing, but your spinal cord knows. Okay, your nervous system knows how your muscle length is changing. So who will detect that muscle length changes? The muscle length changes are detected by muscle spindles. Okay, and they are going to give this information to the nervous system. So let me give you more clarity. Look at here, guys. See, this is your muscle. Now tell me, what are those fibers which I am highlighting here in the black and white color? These fibers which I have highlighted in the black and white color, these are your extrafusal fibers. Okay, and what is this central thing? This is your muscle spindle, which is made up of the intrafusal fibers. You can see these three intrafusal fibers for there. Okay, have I already taught you? It is the alpha motor neuron. It's the alpha motor neuron which is going to cause the contraction of the extrafusal fibers, and the gamma motor neuron which is going to cause the contraction of the intrafusal fibers. Okay, now you look at this diagram and tell me how many intrafusal fibers I am showing here. Three, no? Three intrafusal fibers I am showing. So I am just taking them out. So these are the three intrafusal fibers, which is nothing but the muscle spindle. This whole apparatus is nothing but the muscle spindle. Okay, so this is nothing but your muscle spindle. Okay, now this muscle spindle, what is it? It's a receptor. Receptor. Now you tell me, if it is a receptor, it should be attached with a sensory neuron. Receptors always attached with the first order neuron. Sensory neurons giving the information to the spinal cord. So now tell me, what is the sensory neuron attached to this? The sensory neurons which are attached to this intrafusal fibers are, look at here, 1A fibers. In the 1A fiber are called as a primary fiber, and secondary fiber are 2. So these two fibers, these are the afferents. What they are doing? See, they are taking the information, muscle length change information, and where they will take this information to? They will take the information to spinal cord. And even the secondary fiber also. This primary 1A fibers and secondary fiber, they are afferent neurons. They are the first order neurons. They will take the information up to where? They will take the information up to the spinal cord. Which information? A muscle length changes. So now tell me, muscle spindle made up of intrafusal fibers. It's nothing but a receptor. It is attached to the sensory neurons. Which sensory neurons? 1A fiber and secondary fiber. And okay, have I taught you any motor supply to this muscle spindle? Muscle spindle will also contract. They will also contract. So what is the motor neuron supplying? The motor neuron is called as a gamma motor neurons. You can see here. So it's a gamma motor neurons which is the motor supply, and what is the sensory supply? 1A fibers and secondary fibers. Okay, guys, don't confuse. First of all, these are the intrafusal fibers. There are different types of intrafusal fibers like nuclear bag fibers and nuclear chain fibers. Nuclear bag fibers are of two types, dynamic and static. So there is a dynamic nuclear bag fiber, static nuclear bag fiber, nuclear chain fibers. These are all forming the muscle spindle, guys. Muscle spindle. They are all a part of receptor. Okay, they are detecting the muscle length changes, how the muscle length is changing. And with the help of the primary 1A fibers and secondary fibers, the information is going to your central nervous system. Okay, and they will also contract. That's what I am telling you. Okay, when a muscle is contracting, these muscle fibers, these muscle spindles will also contract. What is the neuron that is going to cause the contraction of this muscle spindles? The muscle spindles are contracted by gamma motor neurons. Again, gamma motor neurons are of two types, gamma 1, gamma 2. No need to remember in that much detail. Just remember what is the sensory supply, 1A fiber and secondary fiber, and what is the motor supply? The motor supply is going to be gamma motor neuron. How a recent exam question was asked? A recent exam question was a histology image. They were showing the histology of a muscle. You know, in the muscle, there will be fascicles present. Okay, in a muscle, what you will see? There will be fascicles, sir. In a skeletal muscle, there will be fascicles. Inside the fascicles, you will be having the myocytes. These are all extrafusal fibers. Okay, this is how a muscle is going to be. These are all fascicles. Okay. Now, what they have asked is, in the center, they have shown a structure, something like that. Okay, they have shown a structure, something like this. They have asked, they have marked this area and they have asked, what is this area? What is this area? That is in the center of the skeletal muscle. What is present in the center of the skeletal muscle? That's nothing but the muscle spindle. That's nothing but muscle spindle, which is a receptor. And they have asked, what is the nerve supply for this? What is the nerve supply? It's a gamma motor neuron. Gamma motor neuron causes the contraction of the muscle spindles, and alpha motor neurons cause the contraction of this fascicles, muscle fascicles, or extrafusal fibers, you can say. Okay. Now let me give you more clarity on this. Okay. The better the clarity, the next topic will be easy for you. See, look at this. Here is your muscle. Let's say this is your skeletal muscle. And tendons. Here I am showing you the spinal cord. Okay, here is a cross section of the spinal cord. You tell me, in the center of the muscle, what do we have? In the center of the muscle, there is this muscle spindle. Okay, here is a muscle spindle, it's a receptor. Okay, muscle spindle, it's a receptor. Now, being a receptor, what it have to do? It have to detect the muscle length changes, whether muscle length is decreasing or increasing. Now, with the help of this primary 1A fibers and secondary fibers. Okay, I am directly showing 1A and secondary both here as one. With the help of primary 1A fiber and secondary fiber, the information is sent to the spinal cord. Okay, spinal cord is receiving the information how the muscle length is changing. Now, you all know from the ventral horns of the spinal cord, who will start from the ventral horn of the spinal cord? It is the motor neurons which are going to start. Now, how many types of lower motor neurons are there? You know, there are two types of lower motor neuron. Now, you tell me, what is this first lower motor neuron? It is coming to the muscle spindle and causing the contraction of the muscle spindle. So, this is your gamma motor neuron. Gamma motor neuron causes the contraction of the muscle spindles. And look at this motor neuron. This motor neuron, it is coming to the extrafusal fibers and causing the contraction of the extrafusal fibers. Okay, the myocytes. This is your alpha motor neuron. Now you understand. So, what is the sensory supply? The sensory supply are the afferents, 1A fibers and secondary fibers. And what are the motor supply? The motor supply is gamma motor neuron to the muscle spindle and alpha motor neuron to the extrafusal fibers. Okay. So, with this, what we have completed successfully, I have explained you the different types of the lower motor neurons. Again, how many types of lower motor neurons? Alpha motor neuron, gamma motor neuron. Both will go to the skeletal muscle. Alpha motor neurons innervate the extrafusal fibers, causing the muscle contraction. Lower, this gamma motor neurons goes to the intrafusal fibers, which are nothing but the muscle spindle. And you know what is the function of the muscle spindle? Muscle spindles are the receptors. Okay, they detect the muscle length changes and inform this information to the central nervous system. Okay, so with this, we have done with the lower motor neurons. In the next video, we will be discussing about the reflexes, the very, very important topic in the central nervous system physiology, reflexes. Okay, normal reflex arc, what are the components of the reflex arc, and I will give you two examples of the reflexes. One is the stretch reflex and inverse stretch reflex, okay, which is very important topic. We will discuss that later. Now, the lower motor neuron topic is completed. Hope the video is helpful. Thank you.